This is part 2, reminiscing about tube testers. I'm trying to, in this two-part series, talk about some of the features and the evolution of tube testers. In the first part, I talked about emission testers, starting in, I think, 1935 with a Dayrad tester made by the Dayton Radio Corporation, or at least its successor. In this part, I'm going to be talking about mutual conductance testers. And really, in talking about mutual conductance, the name that always comes to mind is Hickok. The Hickok Instrument Company, and actually one of its engineers, developed a circuit for testing mutual conductance of a tube. And this Hickok 600A uses that circuit. The same circuit is actually used in all of these tube testers. Now, I've sort of surrounded the Hickok here with a series of 4 B&K testers. B&K was really the most popular tester among service centers, television service centers, starting in the late 1950s and certainly through the 60s and into the early 70s. At that point, B&K had really moved on to some other areas, but one reason that B&K was so popular is because they had a line of television analysts and other test equipment that matched with their testers. Now, the 600A by Hickok that you see here, we'll talk about in a second, but I would like to begin talking about the B&K 500, which was the beginning of the B&K tube tester line. The B&K 500 was called the Dyna Quick by its marketing department, and the reason the Dyna came from the fact that it was a dynamic mutual conductance tester. The Quick came from the fact that you only had to set 2 controls, a filament or heater control to set the voltage of the heater, and a sensitivity control, which on other testers you might see as sensitivity or in the case of the Hickok English, it has a number of names, but basically they're all the same thing. It just adjusts how sensitive the meter is. The reason that the B&K could get away with only having 2 controls, and the reason they called it the Quick, is there were a series of sockets that were wired up for differing tubes. So, for example, if you notice, there are a series of 7-pin tubes here, a series of octal tubes here, and a series of 9-pin tubes here. This is a pin straightener, as is this. There also are connections for top caps, but fundamentally, you simply found the tube on the panel that you were trying to test. You then, the first digit told you the heater, or the first 2 digits in the case of a 2-digit reading, told you the heater setting, that's here. And the second number told you the sensitivity setting. You simply then plugged that in that socket, turned the tester on, and when the tube had warmed up, if you didn't have any shorts, you would go through the tests, GM, life, and gas. At the end of that time, you had tested everything in that tube. Ease of use of the B&K testers is one of the major selling points. The 500 sold pretty well. However, it ran out of steam very quickly because of the rate at which new tubes were being introduced, and it wasn't long until it was replaced by the 650. Now, the 650 was the first extremely successful B&K tester. So let me set up to show you that. Just like the 500, the B&K 650 used a simple setup that is a single socket for each particular socket wiring, so that similar tubes, that is tubes having the same pinouts, were tested in the same socket. So, for example, on this tester, this panel, there is a row of octal tubes here. There are 2 rows of 9-pin and a third row here. Then there is a row of 7 pins. On the expansion chassis, there are, once again, rows of octal sockets. There is a single pair of loctal sockets, and then a grouping of 9-pin and 7-pin sockets. Once again, you started with it in the shorts position. When you turned the power on over here, the power light would come on. If there was an overload, the fuse light would come on, and if you didn't turn it off right away, the light would actually burn out. And that was the fuse. The light was actually the fuse. You would set the sensitivity and the heater voltage based on the readings off the panel, and once again, this is why it was called a Dyna Quick. One of the reasons that they wound up quickly replacing the 500 with the 650 is dual section tubes did not test on the 500. Dual section tubes had become rather popular by about 1958 or 59, and so the Dynaquick 650 had 2 test positions. You notice on the 500 there's only one mutual conductance position, but on the 650 there are 2 called test 1 and test 2. There's even a test 3, which is used to test things like a dual triode diode. In other words, like in some cases, there would be a tube that would serve as perhaps an IF amplifier, an AF amplifier, and the detector, in which case you could test all 3 sections. Eventually, however, they realized that the problem with obsolescence, just like when we talked about emission testers, we discovered that the roll charts, like the one here on the Hickok, were a real nuisance because they were very quickly out of date and had to be replaced. And by the early 60s, these roll charts were being replaced 4, 5, sometimes 6 times a year. What B&K decided to do is, rather than bring out new socket wirings, which was the only way you could update this tester, because instead of simply replacing the roll chart, with this tester, since each socket had to be wired for that tube, or for all the tubes that were like that tube, there was no easy way to test a new tube without wiring up a new socket. Well, that was an even bigger nuisance than replacing the roll charts. So what B&K did was bring out the 610 test panel. The 610 test panel allowed the user to set a series of switches that basically turned one socket into all of the various socket configurations. Similarly, the loctal socket, a 9-pin and a 7-pin miniature, and a top cap. Now, these represented about 99% of the tubes used in televisions and radios that were in current production when this tester came out. And that's all that B&K was interested in. They were not trying to build a tester for legacy systems. However, what they were trying to do was to produce a panel that would keep up with new tube types. And for a while, that's what the 610 did. It added a kind of universal capability to the B&K 650. Why was the 650 so popular? Well, it tested every tube with the best possible circuit. In other words, diodes were tested for emission, triodes, tetrodes, pentodes, beam power, all were tested for mutual conductance. And the 610 extended that capability to the newer tube types. However, you were limited to octal, loctal, 9-pin, and 7-pin miniature. Now let's take a quick look at the Hickok. This was perhaps the most universal tester, or I should say, was the most universal good tester ever built. In my opinion, if you had to own one tube tester, it would be the Hickok 600A. Now, please understand, it depends on what you're going to be using it for. There's a big difference between working on pre-war radios and post-war televisions. There's a big difference between working on tube amplifiers and guitar amplifiers. There's a big difference between working on consumer electronics versus industrial electronics. And so there are lots of different ways you can cut this. But the nice thing about the 600A is, with the series of switches, you could pretty much set up any tube that came out from the early 30s through at least the mid to late 60s. The one drawback of the 600A was it began to run out of sockets when the compactrons and no-vowels came out in the late 60s and early 70s. So if you're doing the late television sets, that is television sets that say came out around or after 1970, the 600A is not a good tester. But for that matter, none of these B&K testers that we've seen so far, the 500, the 650, or the 650 with the 610 test panel, is very good for those either. The circuit in the Hickok was the same circuit that was used in virtually all of the good mutual conductance testers of the time. It's the same circuit that's used in the TV7A, and this particular design was licensed by Hickok to the government during World War II, and they produced buckets full of TV7s, which are essentially the same tester as the 600A. After the 600A, there was another tester that tested some of the new tubes, the new Noval and Compactron tubes. It's called the 6000 and the 6000A. I don't own one, partly because I'm not interested in the television sets after about 1965, but if you are, then that's a good tester also. I'll also show you an alternative to the 6000. But nonetheless, as I say, in my opinion, if you're going to own one tube tester, I'd make it a Hickok 600A. The problem is they're awfully expensive today. So let's look at a couple of alternatives to the 600A that you might want to consider. Next to the 600A is the B&K 700. This tester is basically two testers in one. At the top, this tester is a Dyna quick. In other words, it's very similar to the 650 before it. It has rows of octal sockets, 9-pin and 7-pin. You set heater and sensitivity, you push a button, you do your tests. However, just as with the lesson they had learned with the 650, B&K realized that they needed to make provision for tubes that were not in the wiring of the basic panel. For that reason, they built this panel. This panel basically has a set of switches, similar to the ones on the B&K 610 or similar to the ones on the Hickok 600A, that basically allow you to connect these sockets in a universal way. Also, you may notice that there is a Noval and Compactron socket added. So this is the first B&K tester that could test Compactrons. So in this respect, it's better than the Hickok 600A, it's better than the 650 with the 610 test panel, because if you're going to work on TVs made after about 1965 or 66, you probably will need to be able to test Noval and Compactron tubes, and this can do it. The drawback is it only tests these tubes for emission. Let me emphasize that. The tests up here are tests up on the upper panel. Up here are for mutual conductance, at least in tubes where mutual conductance can be tested. However, the tubes tested on this lower panel are only tested for emission. After the 700 came out, B&K decided to bring out a newer model that they call the 707. They brought this out about the same time that Boeing brought out the 707 jetliner. So I suspect that's where the number came from. I don't know that for a fact. Like the 700, the 707 upper panel tests for mutual conductance. And once again, it has rows of octal, loctal, 7-pin and 9-pin miniature tubes. No compactrons. Just like the 700, it does have compactron sockets, Noval sockets, and the usual 7-pin, 9-pin, octal, and loctal. Just as with the 700, it has universal switch settings. So you could test on the lower panel a tube that you couldn't find a socket for on the upper panel. Once again, however, on the lower panel, you're only testing for emission. On the upper panel, you're doing mutual conductance. You switch between the panels with this switch. That's exactly the same way you switch between the panels on the 700. So there is almost no difference between the 700 and the 707, except the 707 can test more tubes than the 700 because it was a later model. Furthermore, because it has this universal test panel, it is expandable to newer tubes. Now, I did a video some time ago on testing newer tubes on the 650 using the 610 test panel and some related matters. In general, you can do the same thing on the 707 and the 700. However, unlike the 610 test panel, which allows you to test using mutual conductance in a universal manner, neither the 707 nor the 700 does that. But the advantage of the 707 and 700 are they can test the compactrons and the Novals, whereas the 650 cannot. As I pointed out earlier, neither can the Hickok 600A. So as I said before, if I were to own one tester, it would be the Hickok 600A. However, the tester I prefer is this B&K 650, because with the 610 test panel, I can test virtually any tube from about 1940 until about 1970. For mutual conductance, I can do balancing and other things, whether I'm working on an amplifier, a stereo amplifier, a push-pull amplifier, or whether I'm working on a television set or a radio or whatever else. However, I have as a backup my 600A, because if I need to test any of those really old tube types, I'm talking about the 4, 5, 6, and 7 pin tube types that are shown there, then I have to fall back on my 600A, or I have to go to one of the emission testers that will also test these old tube types. So once again, this has been a reminiscence about tube testers. I'm not going to be talking about their circuits, nor about the renovations that I've done on these testers. There are videos on YouTube for every one of these testers, starting with the 500 and the 650, adding the 610 panel, renovating the 700 and the 707. So if you're interested in those, you might want to go take a look at them. But for the purposes of this reminiscence, I'm going to wrap everything up here and say, I hope you've enjoyed this look back at tube testers. I hope you've learned a little something, and more important, I hope it stimulates you to get into working with vacuum tube equipment in whatever way you think will satisfy your hobby interests. In the meantime, look forward to some more videos. I probably will not do much more on tube testers, certainly no more reminiscing, but I will be probably working on some more vacuum tube equipment, and from time to time I'll be using a tube tester in those configurations. So once again, have a nice day, and we'll see you later.